Sorry about that. It was giving me an error message. Okay, so I'm back to the same idea. Two numbers are equal and they have the same base. What has to happen? I'm ready. Must equal. Do we all understand the procedure? Do we understand why those two powers have to be the same? Yes? Natalie? Yes? So, okay, so let's come back here. If this is not 4, so let's say it's 10, will I have this true? No. Right? So it's not going to work because 2 to the 10th does not equal 2 to the 4th. So if these two numbers, I'm told, this side equals this side, and they have the same base, this cannot be 5 and this 10. They have to be the same.
So now, where we're at now is that
we have to solve for x.
Okay.
Yes. So now I move 5x because it's linear, and I move 3. So this is negative 11x equals 17. So x equals negative 17 over 11. And this is the only solution.
So the two bases would just cancel each other out.
I'm sorry?
The bases would just cancel each other out.
Okay, this is exactly how I started. We don't cancel, we don't simplify, we don't touch. Nothing. We only think.
Where are they at?
Okay, so let's think again. Two numbers are equal, and they have the same base. What has to happen? Their exponents have to be the same.
So you're just making a true statement.
That's it. Exactly. I am not allowed to touch bases. I'm not allowed to simplify bases, cancel bases, nothing. I'm not allowed to touch anything.
Go away.
Say it again.
They just go away.
They don't go anywhere. Yes.
So would we put this x in where the 1/8 is?
Let's do it. Let's verify it.
Okay.
Okay. Very good. So we want to check. Awesome suggestion. Thank you for that. So we want to check whether this is the correct solution of this. Very good. So here's my first question for you. Can I check would you agree that if I check in this equation or I check in this equation, I get the same thing? This equation, I took this side to the other side and I put 0 on the other. So are these two equations the same?
Yes.
Right. So if I check negative 17 over 11 in here, or if I check it in here, it's the same. Here's why. I would rather check it in here. Because I'll show you another example in a minute, in which this number will be a result of some calculations. No, it's not. It's just negative 17 over 11. But when it will be a result of some calculations, it's better and easier to recall the answer and put it in here, instead of calculating two different quantities with this number. But since it's the same, this is easier. So let's do that. So in y equals, here's what I'm going to do. Negative 17 divided by 11. Okay, so I have it right there. It's waiting for me. That's the answer that we got from solving the equation. And now I'm copying it in parentheses, 1 divided by 8, close the parenthesis, caret, in parentheses. I have 2 times the previous answer, 2 times the previous answer, which is all this, minus 1, close the parenthesis, and then minus 32, caret, in parentheses, the previous answer plus 4. Good. So now, when I press enter, if this is the correct answer, if it's the correct answer, what should I get when I press enter?
0.
Exactly. If I don't get 0, what do I conclude? Right. Negative 17 over 11 is not the solution. I have to start from scratch. I go back to the drawing board from scratch. Okay, let's see what we get. Now this is the calculator error or the software error. It says negative 1.7 times 10 to negative 9, which means I have to move this decimal point to that side 9 times. 0.0000000017. So it is 0. So 17, negative 17 over 11 is the solution. Very good suggestion. Kelsey, is this okay now? Okay. Thank you. Moving on. So let's look at another type. We are on page 514. Let's say 34, and which we have e to 1 minus 8x equals 7957. Okay, what type of equation is this? I don't see LOG. Good. It is exponential. Very good. Now here's my next question. Can I present e and 7957 with the same base? Nope. No. So I cannot use the same procedure that I enjoyed using here because I didn't have a lot of work to do. So here that was simple. 2 to the x equals 2 to the 4th. Two numbers are equal. They have the same base. The exponents have to be the same. Here I needed a lot of work and preparation. And then when I got here, I said two numbers are equal. They have the same base. The exponents have to be the same. Mandatory. Well, in this case, I can't use the same idea. So there must be something else. Before we work on this problem, I'm going to ask you, remind me how we solve this. What type of equation is it, and how do we solve it? No, it's not a equation. It's something else. What is it?
The answer?
No. What type of equation is it? Very good. Does it have a ratio?
No.
No. Jesse's right. It's a radical equation. Good. How do I solve it? Right. Right. Why am I squaring? Why am I squaring and not, let's say, take it to the 5th power? Because I want to undo the square root. Undoing the square root, I will not use power 5. We'll use power 2. Why? Because the square root and power 2 are what type of operations? Inverses of each other. Right? If I have the square root, I undo it with a square. If I have the square, I undo it with a square root. That's it. So now, keeping that in mind, let's come back to our problem. I need to do something to both sides like I did here. If I square this, I have to square that. I cannot just say, oh, I'm going to square just one side. No, I can't do that. So I have to apply something to both sides here that will undo the exponent. Exactly, the inverse operation. Very good. So I have to apply natural log to both sides. Now the step is pretty similar. Two numbers are equal. Their log in the same base must be the same. Two numbers are equal. Their log in the same base must be the same. So there is one property of the log that allows us to do this. Bring this power in front as a factor. It's the power rule. 1 minus 8x multiplied by natural log e equals natural log 7957. Anyone remembers how much is natural log e? 1. Exactly, right? We remember that? Do I have to show why? It's okay if you say yes. I want you to say yes if it's not clear. Okay, so let's see. So we want to show how much is natural log e. Okay, so this is a number that I don't know what it is, but I know that this is a logarithmic equation and I can change it into an exponential equation. Always start with the base counterclockwise. What is the base here? I don't even see a base. What is the base of ln, or natural log? What did we say the base was? There is no base of 1. E, indeed. So e raised to which power is e? E raised to which power is e? E to 0 will be 1, right? So what power will I have here for this side to equal this side? Exactly. So that's why natural log e is 1. So then 1 minus 8x equals natural log 7957. Do not be bothered by this. It's just a simple number. Okay, I'm solving for x. What will be the next step? I cannot. I have to subtract 1. Awesome. I prefer putting negative in front, but let's write it like this for now. Not to be confused with natural log of that minus 1. Okay? And then final step. By? Good. And now I'm going to rearrange this as negative 1 plus natural log 7957 divided by negative 8. If you want, we can approximate it, and if you want, you can we can check. Yes, please.
Why don't we just subtract, like if it has the natural log and then a number, we can't touch it, right?
Right. This is natural log is applied to that number, and you cannot plug in something inside.
Okay.
Yes. Okay, so negative 1, so parentheses for the top. Negative 1 plus natural log 7957. 7957. Close the parenthesis for the log. Close the parenthesis for the top. Divide in parentheses by negative 8. And close. So we got negative 0.9977. Negative 0.9977. And I hope Natalie would ask again, show me. Okay, here's what I'm going to do. I'm going to change the equation into e to 1 minus 8x minus 7957. Why? Because I just want to plug in one expression, not have to worry about 2 expressions. So I go back. I put e, second and e, in parentheses, 1 minus 8 multiplied by the previous answer, right? 1 minus 8 multiplied by this that we obtained a minute ago. And then minus outside, minus 7957. When I click enter, if the answer is correct, what should this be? 0. Let's check. Press enter, and I got 0, which means that that is the correct answer. We plugged it in the original equation. We only moved one term from one side to the other. We didn't change anything. So that I didn't have to, in this particular case, it's just a number, so it won't have made a big difference. But I may have, and I'll show you in a minute, way more complicated situations in which I don't want to mess with 2 sides. Good. So this is okay. Okay, let's look at one more problem, and then we'll come back with more review when we are done. Okay, so let's say 44. And here is e to 2x minus 2e to the x minus 3 equals 0. Okay. You know me already. I'm going to ask you what type of equation this is. And you will say exponential because it has e to a power that is a variable. But you also have to say, I also see kind of 3 terms, right? Which kind of reminds me of,
Polynomial.
exactly. And because I'm looking at 3 terms, I expect it to be what degree? Exactly. So let's take a look. I cannot move 3 to the other side and say, okay, let's apply log, because I cannot apply log to differences. I can only apply log to a product, to a ratio, or a power. So moving terms around will not help. There is something else from chapter 2, a long time ago, that reminds us of what to do here. Thinking that I have a combination of a quadratic with something else. Is that something that rings a bell?
Can you factor?
Yes, absolutely, that's my target. Now, if I can factor without using a substitution, that's fine. If I cannot factor without using a substitution, then I should use a substitution. Let y be to the, yes, but only if I show and convince you, because otherwise I can't do this, only if I show and convince you that this is what exactly. Because if it isn't, I cannot use this method. What should this be? Exactly. So if I denote the e to the x with a smaller power, right, always, by y, if the first term I cannot show you that it's y squared, then I cannot use quadratic in form. But is it true? If I square this, I get y squared. If I square this, what do I get? I copy the base, and what do I do with the exponents? That's it. So I'm safe. The equation is quadratic in form. So then, can anyone dictate the new equation that we just created together?
Y squared minus 2y minus 3 equals 0.
Awesome. But Harry, if you can factor it without using the substitution, it's fine. Good. So now let's factor.
Y minus 3.
Correct? Good. So there are 2 options for y. What are they? Very good. So now the first equation, y equals 3, doesn't mean anything till I change it into, yes? Go ahead.
E equals
E
or E.
to x.
E to x. That's what y is. Equals? Good. And then y equals -1 really means what?
E
Yes?
equals to
Good. So I have to first solve the first equation. How do I do that? I'm asking myself, say it again. So we have e to the x equals 3. So I'm asking myself, what is it? Okay, it's exponential. Can I present e and 3 with the same base? Oh, no. So then what do I have to do? What is the only method that I can apply if I cannot present both sides with the same base?
The same X.
Apply? Very good. Apply natural log to both sides. I bring x in front, but x times natural log e. How much is natural log e? Very good. So this is natural log 3. So that's our first solution. What about the second equation? What would you recommend we do? We would recommend it's the same idea, right? To apply natural log. But what could be the problem now?
Negative.
Exactly. Can I apply log to a negative number? No. So stay with me, please, just 1 second. E to the x, if you remember, here's how e to the x looks like. This is e to the x, and an exponential function with a base greater than 1. So this is this side. Now let me graph -1. Y equals -1. So this is y1 and this is y2. In how many points do these two curves intersect? Never. So that's why I'll say no solutions. However, the original equation has one solution, which means x equals natural log 3. Any questions? Any questions? Okay. Ready? So now let's look at log equations. Okay. Now, what did we say about the exponential function? Is it a friendly function or does it have restrictions? Look at the graph. Does it have restrictions?
Has to be all.
All the numbers, no problems whatsoever. That's why we did not state any restrictions when we solved exponentials. What about log? Is log a function with restrictions or is it a friendly function?
Has restrictions.
Yes. So therefore, every time we solve log equations, we have to state domain. State domain. This is one option. It's up to you which one you prefer. I'm fine with both. One of them is state domain, and the second option is check. Check the solutions in the original problem. It's up to you which one you prefer. I will take the first one. Why? Because I'm notorious for forgetting to go back and check. So I prefer to state the domain. You don't have to be consistent. You can solve a first problem stating the domain and second one checking. It's up to you. But I prefer this one. So here's our first example, 72. Log base 4 of x plus 2 minus log base 4 of x minus 1 equals 1. You know my first question. What will be my first question? Say it again. Thank you. I know I sound like a broken record. Yes. What type of equation is this? Very good. It is a log equation. So now I'm going to ask you, what do I have to write for this function to exist? What do you think? Say it again. Oh, I can because this is not an equation that involves just that portion. I'm only asked to find the domain right now. I just want the domain. Go ahead, just give it a shot. X plus 2 must be what type of number so I can apply log to it? What type of numbers I can apply log to?
Positive.
Exactly. What will I have to write for this to exist? X minus 1. Very good. Awesome. So these are the only two restrictions. There is nothing that I have to write for the right-hand side. So I will copy the first. I will copy the second. I will solve both x greater than -2 and x greater than 1. I will graph them on the same number line because I want to make a decision and I need the common domain. So remember, I don't care for units here. So I just care about being exact, but not accurate. So -2, greater than -2, and 1 and greater. So what is the common domain here? Which territory will I have to pick so that both log functions in our equation? I cannot do anything or change the equation before I state the domain. So where will the solution be unless the equation has no solutions? Where should the solution, if it has one,
1
Or-
to infinity.
1 to infinity, obviously that's where the common domain is. So when we solve the equation, if we don't find a number as the solution between 1 and infinity, I'll say no solutions. It's a contradiction equation. Good. Finally, now I can go back and say, good, I need to condense the left-hand side. And the log has 3 properties. 1, log applied to a product, which is the sum of logs. Should I review this? Should I write those 3 properties one more time? Okay. So log applied to a product is log x plus log y. Log applied to a ratio is log x minus log y. And log applied to a power, which we already used a couple of times already. Okay. So now I'm coming back knowing that these are the only 3 properties that the log has, and I'm going to ask you, how do I condense this? What will you say? Good. So,
Ratio.
yes, I'm ready. So tell me how to write it and I'll write it. Say it again.
We divide it.
Log of 4.
Log base 4
Base 4 of to the x minus 2, or the x plus 2 power
over
over
X minus 1.
x minus 1 equals 1. So we indeed use the second property, right? Because there was a difference between 2 logs in the same base. So then I'm using this property going backwards. So I have the difference here. And all I have to do is copy log base 4. The top is this one because it has positive in front. And the bottom is coming from the second one because it has minus in front. Is this clear?
Yes.
Okay, perfect. Yes?
Yes.
Oh, very good. So now this is a pure, simple, I shouldn't say simple, pure log equation. And I know that the most important concept in this chapter is that I can change any log equation into an exponential equation. And I'm ready.
Yes. Log is
How do I change it? Say it again.
4.
It's already log. I'm changing it into exponential.
That's 4 raised to 1.
Yes, 4 raised to 1 equals?
X plus 2.
Very good. 4 raised to 1 equals x plus 2 over x minus 1. Awesome. That's how we change the log equation to an exponential one. Perfect. So now I have to look at this one. And again, my wheels are turning. What is it? So I know what to do. What is this now? Now forget about that. I changed it into this. But now what is this and how do I handle it?
That's power.
So the left-hand side is 4 or 4 over 1. The right-hand side is x plus 2 over x minus 1. And that's my hint for you.
just cross multiply.
Exactly. It's a rational function, a rational equation, so I have to cross multiply. Very good. 4x minus 4 equals x plus 2. Now what is it? What type of equation is this?
Linear.
Very good. So I'm moving x, I'm moving 4, and I get x equals 2. But I don't know. Because I'm solving a log equation and I have to use one of these two methods. Either I state domain and check against the domain or check the solutions. But I have the domain. So what do I conclude? Is this correct? Yes, it is. Yes. Because it's in the common domain, 2 is somewhere in between 1 and infinity, and it is correct. This is how we solve log equations. Let's look at another. And then look at word problems. Any questions on this? Any questions? Okay, so on the same page, 515, let's look at 76. Log base 2 of x minus 3 plus log base 2 of x minus log base 2 of x plus 2 equals 2. Log base 2 of x minus 3 plus log base 2 of x minus log base 2 of x plus 2 equals 2. Okay, so my first question is, what is it?
Log equation.
It's a log equation for sure. Good, so let's identify the domain for each piece. So what will be the domain for this? What do I have to write in order to find the domain eventually for
X
this?
minus 3 greater than 0.
X minus 3 must be?
Equals 0. Greater than 0.
Very good. For this one,
X
must be?
greater than 0.
Awesome. And for this one?
X plus 2 greater than 0.
Very good. So these are the three conditions, one for each log. Otherwise, log will not exist. I'm going to put these three together. X minus 3 greater than 0, x greater than 0, and x plus 2 greater than 0. And I will solve all of them like I did before. I will graph all of them on the same coordinate system. And find the common domain in order to establish where the solution should be. Okay. Greater than 3. Greater than 0. And greater than negative 2. I need the territory that fulfills with all three conditions at the same time, where I can pick numbers and all three logs will exist. Indeed, absolutely. So the common domain is 3 to infinity. If I do not get a solution that is strictly greater than 3, it will not be accepted. Is that clear? Everyone? Yes? Okay, very good. So now, let me draw your attention to how to condense the left-hand side. Okay? If a log has positive in front, its expression is coming from the top of a fraction. If it has minus in front, its expression is coming from the bottom of that ratio. If you remember that, then we will be able to condense it in one step. So what will you say? Log base 2 of?
X minus 3
Yes?
multiplied by x
Good. I'm going to write x times x minus 3, which is the same thing. Very good.
divided by x plus 2
Very good. Equals? Awesome. So I completely condensed the left-hand side in one step. And now what am I going to do? I'm going to
Is this where you call 2 to the
Exactly. Change this into an exponential equation. Awesome. Because we know that the most important concept in this chapter is going back and forth from a log to an exponential and vice versa. Okay, I'm ready.
Because x.
Yes, I'm going to distribute x squared minus 3x over x plus 2. Very good. What now? Now I'm asking myself, what is this?
So
How do I solve it? First, I have to identify what it is. What is this? Right, which type? Exactly. 4 over 1 equals x squared minus 3x over x plus 2. Say it again. Jesse? You had a question?
no, it's not right.
Is it clear? Okay, so then 4x plus 8 equals x squared minus 3x. But now, what type of equation is this? Yes. If it is quadratic, and I have to set it equal to what?
0.
Exactly. So I have x squared. I'm bringing 4x minus 7x and then minus 8. So I set it equal to 0. And now what?
Oh, right.
Yes, very good. So let's factor. X minus 8 indeed. X plus 1. So then you're going to give me two solutions. X equals 8. And I'm going to say, or I'm sure you're going to say that to me, not too fast. Right. This is what we concluded before we started. So then, what is the conclusion? One more time. It doesn't fit the common domain. 1 or 2 or all 3 may not exist. This is the way we solve log equations. Any questions for me? I know that's not enough. Say it again.
Can you pull it down a little bit? Like the copy?
Yes. Any questions? Any questions? It's not enough. We will have more examples and we will review this with more. Any questions? But we have an idea of what to expect, right? Okay, so let's look at applications. 4.5. That's where you come into play, and I'm hoping that between now and Thursday, you will find the time to work on as many problems as possible and come back and say, you haven't showed me a problem like 37, and I will. Or say, you haven't shown me a problem like 77 in 4.4, and I will. Yes? I'm sorry? Everything. Till 8.1. Okay, applications. There are few models in this chapter, in this section. Here's the first one. Exponential growth model. You do not have to memorize it. It will be given to you. Bacteria grow exponentially. Populations. Not just people, fish, mice, rats, bats, and so on and so forth. They grow exponentially. The model in your book is this. I don't particularly like it, but I'll use it. The correct model is n of t, where n0 is the initial number, and e to rt, where r is the growth rate. It doesn't really matter. They're just different notations. Same thing. So we'll have an application in a minute. Number 2. So this is the exponential growth model. Bacteria populations, they all grow exponentially. The exponential decay. It's for radioactive substances. They decrease their mass in time. So n, this is number. M of t equals m0 e to minus rt, where m is mass. And m0 is the initial mass. And of course, your book doesn't like this. They use this. It's the same thing. All the same. T is time. You do not have to memorize the models. They will be given to you in the problem. The third one is the logistic growth model. And this one has many, many different presentations. So let's start with the problem. 37. On page 530. Let's read the problem. The logistic growth function, f of t, equals 100,000 divided by 1 plus 5,000 times e to minus t. This is a logistic growth model. Okay. First question. Oh, first of all, I have to identify what they mean. F of t, number of people. Who have become ill with influenza, t weeks after its initial outbreak, t in weeks, in a particular community. First question, part A. How many people became ill with the flu when the epidemic began? How many became ill when the epidemic began? Exactly, thank you very much. So I have to find f of 0, and we will in a minute. Part B. How many people were ill by the end of the 4th week? Exactly, very good, thank you very much. And we'll come back to C. So let's go to y equals. Okay, let's go to y equals 100,000 divided by, in parentheses, 1 plus 5,000 times e, in parentheses, negative x, close the parenthesis, and close the outside. Do we have this already? Yes? Okay, and then we go to second and table. And I am going to plug in 0. And I am going to plug in 4. Okay, so for 0, 20 people. And for 4, 1,080 people. Final question here. What is the limiting size of the population that becomes ill? Which means, okay, initially we had 20 people, then 4 weeks later we had 1,080, and then 10 weeks later we had more, and then 12 weeks later we have more, and more, and more, and more, and more. Is there a limit? And the reason is, of course, we assume if there is no visitors and nobody goes from town to town, what can happen is everybody gets sick in that community, but not more, assuming there is nobody from the outside coming in. So I don't know what's happening, but I'm going to say, okay, let's see what happens after 40 weeks. 100,000 people. Let's see what happens after 100 weeks. 100,000 people. Let's see after 700 weeks. So then the higher and higher and higher the number of weeks, then more and more time passes. What is the maximum possible number of people who can get sick? 100,000. Which means for, what does this mean for this function?
Max.
How is it called?
Is it you have an asymptote that
Horizontal asymptote y equals 100,000.
that's because the numerator was the 100,000. That's
Because the numerator was 100,000. So I will say, as t increases without bound, f of t approaches 100,000 people. Very good, because it was a combination of rational with exponential. Okay, I'd like to look at another problem. Okay, on page 539, problem 26. Remember I gave you a copy of some previous tests. Please bring them with you, not necessarily Thursday, but next week, so we can go over problems from there. I gave you 3 different colors, so bring them with you next Tuesday. Okay, the function a of t equals 82.3 e raised to negative 0.004 t. Models the population of Germany, A in millions, so this is millions, T years after 2010. T is number of years since 2010. What was the population of Germany in 2010? How do I determine that? What was the population of Germany in 2010?
So if you're starting at 2010, t would be 0.
Absolutely, thank you. So A of 0. Okay. So how much is negative 0.004 times 0?
0.
How much is e raised to 0? Careful. E raised to 0 is 1. And how much is 1 times 82.3 million? 82.3 million. Well, we knew that, right? Because the model is A of t equals A0 times e to negative RT. And A0 is the initial value. Part B. Is the population of Germany increasing or decreasing? Decreasing. Because of the decay model. The decay model has minus. Okay. In which year will the population of Germany be 79.1 million? In which year the population will be 79.1? What am I given? What am I asked to find?
Given
Given the
good, but
oh, you got this. Don't let me stop you. Go ahead.
right, given the beginning
The y value, indeed.
and
Yes. 79.1, I'm given this value equals 82.3 times e to minus 0.004 t. Very good. Okay, my next question to myself is, what type of equation is this? I have to look carefully and identify where the variable is and what type of equation. Exponential, right? We agree? The variable is at the exponent. Perfect. Okay, what do I have to do first?
Make the basis.
Say it again. I cannot. I cannot. I always hope to make the basis the same, but I cannot in this case. I cannot apply log just yet. It's not cleaned up. It has to be completely cleaned up. What will I have to
Take
do?
the exponent and put it in front.
No,
Or the-
that will happen after I apply log. And I cannot apply log just yet because it's not completely cleaned up. Say it again. Not yet. Before I apply natural log, I need one more step to clean it up.
You want to try to get rid of a negative exponent?
No, I cannot unless I apply the log. There is something in the way. What portion of all that is in the way? T is what I'm solving for.
Maybe get rid of the e and
I cannot.
the 82 and put it on the other side.
I cannot. I have to divide.
Yeah.
I agree. I have to divide by this first. Because if I apply log, then it's going to be a sum because it's a product. So careful on that. So first I have to divide both sides by 82.3. Not actually divide it, but write it like this. And yes, now I can apply natural log, and I have to. So it's natural log on the left, natural log on the right. The left-hand side stays as natural log of 79.1 over 82.3. And what do I have on the right-hand side? I have to bring the power first. That's why I'm applying natural log, to bring the power in front.
That's just times 1, right? So that
Yes.
goes out the-
And then times natural log e, which is 1. Very good, awesome. And then finally t equals, what do I have to do in order to get t by itself?
Divide.
Yes, both sides by.
0.00 or yeah, negative 0.004.
That's it. You understand why we needed to get rid of 82.3? Because then when we apply log to both sides, and we apply it to a product, and I have to separate it into a sum. So it's more complicated than if I get rid of it. So in y equals, please clear and clear everything you have in there. So natural log 79.1 divided by 82.3, close, and divide by, in parentheses, negative 0.004, close, and enter. So 9.91, what does this mean? 9.91, what is the measurement unit? Years. And that means what year? 2010 plus 9 is 2019. Any questions for me? Any questions? Any questions? Yes? Any questions for me? Any questions? Okay, chapter 5. 5.1 is a review from a previous course. It's solving systems. Of 2 by 2, which means 2 linear equations in 2 variables. two linear equations in two variables. Two linear equations in two variables. The methods that we will refresh our memory on are substitution and elimination. In some books, the elimination method is called the adding method. I agree with both. Either you call it elimination or you call it the adding method. That's fine. Okay. So let me pick an example if you want to. If you have your book, you can pick. We are on page 555. If you trust me, I'll pick a problem. If not, I'll let you pick. You want to pick, Damon? From 5 to 18?
Okay.
Yes, please.
All right.
And then I would like you to pick from 19 through 30. I need an example from 5 through 18 and an example from 19 through 30.
Okay, let's go with 7.
7 it is. 7 it is here.
21.
Very good. 7 and 21. Perfect. So let's copy 7. X plus 3y equals 8. And then y equals 2x minus 9. In problem 7, we are asked to solve by substitution. And I see that the second equation is already solved for y. Because it's already solved for y, all I have to do is replace y in the first equation by 2x minus 9. Because y is the same with 2x minus 9. So then the new equation becomes x plus 3 in parentheses 2x minus 9 equals 8. So we substituted y in the first equation by what it was equal to from the second one. So in the second one I see y is the same thing with 2x minus 9. So all I had to do is just replace y by 2x minus 9.